Here is the spreadsheet, which is the part number database for our class. And it's pretty darn small. It's just a tiny little database. It's an Excel spreadsheet. And I have created part numbers for each of the items that we might use in our drawings in this class and next term. Now, there's a whole specialty to designing part number systems. I'm no specialist, I can tell you. And there are several things that you might need to think about if you are ever in a position where you are setting up a part numbering system. And the first decision is, are you going to make significant numbers, smart numbers, or are you going to make randomly generated next available number? I am a fan of significant numbers, so you'll notice all the plate and sheet metal is in the 110-10. The flat bars are 110-20 and so on and so forth. And fasteners are in a different category. They're down in the 231s and so forth. I find that easier to use. There are trade-offs. If you do a thing like this, you have to plan way ahead and leave plenty of open numbers for the future for when you have a bunch of new parts added. Some companies around town use 5-digit or 7-digit numbers. I think Peterson uses 5 digits plus some others, and they use just next available number. So you'll see a piece of plate right next to a conveyor pulley and so on and so forth. So there you go. This is our part number list anyhow. And I've put this in a couple of places in our course. One right next to where you need it today, and I've also put it up in the general course information. So let's think about part numbers now. In your company, your part numbers are used for a lot of different functions. Every item in your company has a part number, and you use that, or someone uses that, to keep inventory. So they're recording how many half-inch hex bolts do we have. Well, I'll look up the part number for half-inch hex bolts and it will tell me. You use those part numbers when you generate bills of material. So you get the part number for a half-inch hex bolt and you write it on a bill of material. And now some production planner can go and look at these bills of material and see, I've got bills of material with demand for, I'm going to need 1,000 of these half-inch hex bolts next month. I'd better look in my inventory of those things and see how many I have and how many I need to order, and so on and so forth. Let's see. We did talk about this before, so this is a bit of a repeat. Just a reminder that you're entering your part number in the bill of material. And so here are the part numbers. You'll notice that I've divided them by plate and sheet, by structural steel shapes. Here are pipes and fittings. These are the ones you're going to need. Here are some other kinds of metals and some fasteners. So you just look through here and find the category that you need and get your number. Here's a close-up of the section that you'll need for your pipe handrails. Here are part numbers for various sizes of pipe. 3 of them are standard Schedule 40. Then there's a big Schedule 80 and a big Schedule 160. Here are part numbers for several pipe fittings. Now notice the elbow, we're going to use welded fittings, and notice the elbow is not called elbow. It's called L, E-L-L. Then here is a T, welded T, and here's a welded cross. And we're using all 1.5 inches, so you can ignore the 2-inch and 3-inch elbows. Notice the next column over Do you know what UOM is for? It's unit of measure. Pipe has a unit of measure that is linear feet. So your production planner or your inventory person is going to record how many linear feet of pipe they have in stock. Fittings, on the other hand, it's nonsensical to record linear feet or square feet. We record them as each. So do we have 1 elbow, 2 elbows, 100 elbows? Those are eaches. For some of the materials in our bill of material, I got industrious and entered the weights using, I think for the pipe, I used the Far West Steel catalog. I didn't get the weights for the fittings, sorry. So if you're looking up how much does a foot of 1.5" standard pipe weigh, you don't need to for this assignment. I'm just saying if you wanted to, you would look and see it weighs 2.718. What? Well, the weight per unit of measure is pounds, and our unit of measure is linear feet. So what we see here is 1 linear foot of this size pipe weighs 2.718. So you could go figure out how much your handrails weighed. And if this were entered in a computer system, and no doubt it would be in your company, your planning system could automatically tell you how many pounds of 1.5" pipe you have sitting on your rack there. Then you've seen these slides before. So your item number bubble will go in your bill of material. Your quantity will go in your bill of material. Here is the part number. This is what we're talking about right now. So you come over to your part number spreadsheet and find the part number for 1.5" pipe. Then you copy the description. So you come over here and find 1.5" pipe is pipe 1.5, schedule 40. You write that in there. And then if it's something like pipe, you might want to be helpful and write the length of pipe in here. If this were an entry for a fitting, then putting the size in here wouldn't make any sense, so you just leave that blank. And again, here's this close-up of our part number list. So if you are listing a fitting, here's the part number for your elbow, your 1.5" welded elbow, and we see its unit of measure is each, so no point putting a length in our bill of material. There you go.